Have you ever wondered why pushing a loaded cart feels much easier than carrying the same load? Or why riding a bicycle lets you travel farther with less effort than simply walking? Every day, we use tools and machines that make our work faster, easier, and more efficient. But here's the exciting part: they all work because of the same scientific principles you've already learned: translational motion and rotational motion. From the wheels of your bicycle to the scissors in your pencil case, motion makes these machines work. Today, we'll discover how these two types of motion help us design efficient, simple, and compound machines. And by the end of this lesson, you'll be thinking like an engineer, ready to create machines that solve real life problems. Machines do not reduce the amount of work that needs to be done. Instead, they make work easier by changing the size or direction of the force we apply. A machine is considered efficient when it transfers most of the energy you put into it into useful work while minimizing energy losses caused by friction, heat, vibration, or deformation. Think about riding a bicycle with rusty chains. You have to pedal much harder, yet the bicycle doesn't move as smoothly because some of your effort is lost to friction. Now, imagine riding a clean, well maintained bicycle. With the same amount of effort, you travel farther, faster, and more comfortably. This is efficiency in action. Efficient machines require less effort to perform a task, reduce energy losses due to friction, use strong but lightweight materials, remain durable, safe and stable, have properly aligned and well maintained moving parts, and perform their intended functions smoothly and consistently. Whether you're using a hammer to drive a nail, a wheelbarrow to carry heavy loads, or an elevator to reach another floor, these characteristics help machines save both time and energy while making everyday tasks much easier. Machines come in different forms, but they all begin with a simple machine. A simple machine has only one basic mechanism that changes the direction or magnitude of force. The six classic simple machines are the lever, wheel and axle, pulley, inclined plane, wedge, and screw. If you look around your classroom or home, you'll discover many examples. A broom works as a lever, a doorknob is a wheel and axle, a knife acts as a wedge. A ramp is an inclined plane. A ball uses a screw, and a flagpole operates with a pulley. But what happens when two or more simple machines work together? They create a compound machine capable of performing more complex tasks. A bicycle combines wheels, gears, levers, and axles. Scissors combine two levers with wedges, while a wheelbarrow combines a lever with a wheel and axle. Even a can opener uses several simple machines working together. By combining different simple machines, compound machines allow us to accomplish work more efficiently and with much less effort. So, what actually makes these machines move? The answer lies in translational motion and rotational motion. Translational motion occurs when an object moves from one place to another. Imagine a shopping cart rolling through the supermarket, a wheelbarrow moving across a garden, or an elevator traveling upward inside a building. In each case, the entire object changes its position. Rotational motion, on the other hand, happens when an object spins around a fixed axis. You can observe this in bicycle wheels turning as you ride, gears rotating inside the clock, an electric fan spinning to cool a room, or a screwdriver twisting a screw into wood. Interestingly, many machines use both types of motions at the same time. As you ride a bicycle, the wheels rotate while the bicycle itself moves forward through translational motion. Inside a sewing machine, rotating gears move the needle up and down to stitch fabric. In an electric fan, the motor rotates the blades, creating moving air that cools the room. By carefully combining translational and rotational motion, engineers create machines that are faster, stronger, safer, and much more efficient. Now, it's your turn to become an inventor. Imagine your challenge is to build a machine that can help carry heavy books across your school campus using only recycled materials. Before you begin building, think like an engineer. Ask yourself whether adding wheels could reduce friction, whether using a lever could make lifting easier, whether a pulley could help raise objects, or how you could combine rotational and translational motion to make your design work more efficiently. As you sketch, build, test, and improve your prototype, you'll also be developing valuable 21st century skills such as critical thinking, creativity, collaboration, communication, and problem solving. Remember, many of the world's greatest inventions did not begin with expensive materials or advanced technology. They started with a simple idea, careful observation, scientific knowledge, and the determination to solve a real world problem. Every machine we use today began as someone's idea. By understanding how simple and compound machines work, and by applying the concepts of translational and rotational motion, you can design solutions that make everyday life easier, safer, and more efficient. Keep exploring, keep inventing, and let science power your ideas. Don't forget to like, share, and subscribe for more exciting science adventures. See you in the next lesson.